the data points do not change. These new updates in A5 really give you a lot more power in creating nice box plots. I want to caution you that these sample size that we're mentioning here, these n sample size, are per page. So this is a count of this formulation per page. If I want to split this graph, maybe by gender, going to the setup and selecting gender as a stratification, maybe I want the gender in two different column graphs. I need to change this to display most of our data. The n here represents the total values for this formulation. So therefore is adding both of them. So when you're latticing plots, please make sure that you understand that the n is the total. If you wanted n for each individual box plot, you would need to set that gender to be a page sort. And therefore by page, you would get the correct sample size for each box plot. Okay, I hope that makes sense and folks are excited about it. So let's recap some of these enhancements. We talked about this ability to retain the appearance of the settings for group variables. So the colors, the markers, the line width, etc. And this is retained when you copy that object and when using workflow templates and plot object settings. In the previous version, these were being redone and you may get different colors when in this new version, you can select the colors that you always wish to keep. We also talked about user-defined tick marks that they're now available for the XY plots. Adding grid for minor tick marks is also available. And in box plots and categorical X plots, you can display the number of groups. And in the box plots, in addition to displaying the sample size, you can also remove some of the box plots if they don't meet a minimum number. I'll also like to point out that in previous versions of Phoenix, in some cases, you might see some spacing between the box plots. This was due to the fact that this data set has a time 3. However, that time 3 has all BQL values or values that are not numeric. Previous versions of Phoenix will detect that time and save a space, but the data would not be plotted. This has been removed in 8.5, and that spacing is now gone. I'll also like to point out one other difference in the plot defaults under preferences. These are defaults that are applied to all the plots at a system level. So if you want some type of font to always show up in the plot, you can set it here. You can see that in A5, there's two other options. So you can set the legend text wrap size. There's also a plot matrix tick label offset that the default can also be set here. These are the changes to plots. Now let's take a look at some of the improvements to tables. I will create a table of concentrations per time. So I send this input data set to a table. I select subject, period, and sequence as row ID. Concentration will be the data to be displayed in the body of the table. And then I will stratify by row on formulation and gender. And I will present the time as a column stratification. So the time will go across the top. Now I've created this table that shows at each time point what the concentration was for a formulation group, a gender group, and then each subject in that category. Many times you may even have other row stratifications. This table may become really wide with a lot of empty space. Let's add a couple more here. Now I added study and matrix also as row stratifications, and the table is becoming wider and wider. Now in 8.5, you have the option to remove these columns and add this information as part of your title. Let me show you how to do this. Phoenix 8.5 allows you to remove these columns and make them part of title. The first thing that you need to do is to map this data as a page stratification. This is new. This column here was not in previous versions. If I select page stratification for all these variables, the display will look the same to start with. However, you have an option in the titles now to move the pages certification to the title. By clicking this, will also give you tags of these pages certifications, meaning this tag will put the value in the title. You can embellish this title to say study X. Maybe this is a tabulation of just the value of the matrix, like plasma, concentrations over time. For, let's say, males and females, so I'll take this tag. So it's just the name of the column framed by a pound sign. Take in this formulation. You can change these titles, fonts, alignment, whatever you want to do with it. So maybe I want it to be bolded, much bigger, and centered. Once I rerun this table, these titles now appear on the top, and those page stratification columns have now disappeared, making this table a lot more concise. And of course, if the values change, so for example, I have females here and males here, they are separated in different tables and the titles change with the values that are being presented. I can make changes like these. I want to be plural, I can put an S, so now it reads for females. There's also improvements in the precision. Let me first, though, add a couple of statistics here. We will add N, mean, and the CV%. You may also want to change the precision of the values on the table. So often you may want to use significant digits for concentration data. And we can do these at the highest level where we can select the significant digits to be equal to 3. This is something that you've been able to do before. As you can see here, some of the precision now looks a little bit strange for a time to be presented this way, for period subject to have 2 decimals, etc. So you may want to change some of the precision for particular variables in the table. In 8.5, what has changed is the capability of doing this simultaneously for multiple variables. So I can select, for example, subject, and then I can do period by doing shift click because they're next to each other. I can also use control click to select time. Want these in decimal places of maybe 0, no decimal places. So they will show as integers. This works nicely for subject and period, but notice that for the time, it now changed the 0.5 to a 1. So that wasn't exactly what I needed. There is another option in 8.5 to remove trailing zeros. So I may want to keep these to 1 decimal place, but remove trailing zeros. That means it's going to remove any trailing zero that follows the value. So instead of presenting 0.0, it removes that 0. But now that I have a 0.5, it just removes the zeros after 0.5. Very helpful. I can do that for N too. So in the statistics, I can select the N for concentration to remove the trailing zeros. Removing trailing zeros means that it removes one or more zeros if they are the rightmost digits in a number and occur after the decimal point. Also in 8.5, this window is now adjustable, giving you more space to make decisions. A quick recap of improvements to tables. I've shown you how the titles have changed. Now you don't need to add one by one, but you can add the titles here and edit them as you need to. You can also map pages certification and move those pages certification values to the title. Therefore, from this view, it can go to this type of view, and how you can multi-select in order to change the precision and remove trailing zeros if needed. Let's move on to Reporter. To show the new capabilities of Reporter, I will insert a Reporter object into this workflow. As many as you know, Reporter is a tool to help you compile a Word or a PDF report for your Phoenix work. For this quick demo, I will just add all the tables that exist in my project. So I click all tables and you can see that you can change the order of these tables and you have some settings for each of the tables. But what I first wanted to show you is I may have a table like this that has several NCAPK parameters that is quite wide. If I create a report with this table, we can see that this specific table got split in a way that there was only one parameter in one of the page. This is because of the default setting of a split at page width. So it depends on the page width. If I set it up as landscape, it would be a different type of split. However, this new option, you can split evenly across pages. So based on the pages that it took, the system will count the number of columns and it will divide them evenly. There are 3 pages, and then based on the number of parameters, those will be divided evenly. Let's see that. I select the split evenly across pages. This is the new addition in 8.5. And now this table continues to be 3 pages, but they're more evenly distributed. 3 parameters per page. The last page here now showing also 3 parameters. These might be helpful depending on the type of table that you're doing. What I want to show you next is an update in 8.5 related to context footnotes. If I click on the settings for this table, I can go to footer and find the contextual footnotes. Now, because this is my first time in the system, I would need to add them, but those are remembered going forward. So I can add how I want this footnote to look like. I can also set the font for this. We'll make it 6 and save it. And I can add a few more. Let me add a few to show you the new option here. This would be a no sample, also smaller, and one more. We'll add an asterisk for maybe excluded from descriptive statistics. As I mentioned, these are remembered. The update here is the order of these contextual footnotes. You can switch the way they're going to be presented if they happen to be in the same table, so they can be moved up or down. So I can move BQL down, make it go back up. Let's see an example of this. I select those 3. Let's click OK and run this. In table 1, we see a footnote for BQL. And in this page, we see both of the footnotes. Now I can change the order here in 8.5 just by going back to the footer, switching this around, and rerunning. We'll find that same page and confirm that this order is now opposite from before. So these are the changes that have been implemented to the reported object. Now we will discuss NLME. The first NLME enhancement that I would like to mention is the addition of a code block in the graphical mode. This new code block allows users to add any code text inside the graphical mode. This is useful when you want to represent something graphically to be able to explain it, but you couldn't do that before because you needed to code certain parts of that model. This new block code is most useful with the sequence statement, which is the only PML statement where the order of the statements does matter. For example, sequence statements are useful for specifying actions that occur at specific times in the model. Like we have here, we're initializing a compartment. Let me show you an example where this code block can be used in a change point model. I should now be sharing Phoenix where I have uploaded a new project. This is an example of a change point model where parameters can change in non-continuous specific times. So it can be like a shift in the absorption or other. Let me show you. Now in the graphic model, you can keep the graphic of this PK system, but you can add a code block. To add a code block, you just right click, insert, and you just select code. Then you can change the name of your code block and you can enter your PML code. Delete this one and just show you this one. We're saying that this parameter Ka, an absorption rate, this is being linked into this rate constant Ka. It's equal to something that we are going to estimate, but after a certain amount of time that we're calling a lag 3, that rate changes to a different rate. In our case, this is going to be slower and the second one is going to be faster. So you can write this with a sequence statement, and we could have done that in code, but this gives us the possibility of keeping this type of diagram, which might be easier for some folks to understand. But if I go to the initial estimate, you will see what this model is trying to describe. So you see here, there is a rate of absorption, and then after some time that we're going to estimate, there's a second rate of absorption before we get to the maximum absorption. Now, the nice thing about this, if you go into textual, if you click here and edit as textual, it will remember this block. So going to textual, we'll just put this whole block on top. But if you ought to go back to using as graphical, it will only remember what you did in the graphical mode. Everything else that you typed in textual mode would be lost. So some folks that are more used to using the graphical mode instead of the textual mode may find this new code block useful. Another nice improvement in an LME is a new statement called BCV fixed, which stands for variance covariance fixed effects. This statement is only read when you are in simulation mode and is ignored otherwise. What it does is allows you to put variability to your fixed effects as well as your epsilons. Let me show you an example to better understand this useful statement when doing simulation. I have uploaded a couple of projects here. And I wanted to remind you that when you're doing a model fit, you get results in a population model for the typical parameters as well as your sigma. And these are the estimates that later on one could use in simulation. However, these estimates have a precision that is not taken into account replicate by replicate. If we do want to take them into account, and that means we want to incorporate parameter uncertainty between replicates in simulation, we can use the new statement. But if we're not using this statement, just wanted to show you that whatever is entered here as an initial is really the estimate that we're using in our simulation. These values, you can see here from the output, do not vary between replicates. Replicate number 47, you will see that they're not buried. Now we get different estimates per ID. That's because of the between subject variability, the ADAs. But these fixed effects are the same. If we use the new statement, and I've taken advantage of the new block code. So I'm using the graphical model with a new block code, and you can see here that I've added this statement. Now, in this case, I'm only adding variances. I'm asking the model to sample from a normal distribution with the mean being the typical value and the variances that I've specified here. Now, I've calculated this to be 10%, okay, and translated it in terms of variances. You can already see in the results that my typical values are not the same ones that we started with. So this one is not 0.36, and it varies per replicate. So you see here that these typical values are now being sampled and they vary. If I summarize this, you will see that the means do end up being pretty close to the typical value estimates, but there's variability in them and they correspond to about 10%, as you can see here. So I've done these for 5%, 20%, 30%. And if you plot the concentrations that come from this type of uncertainty, this is with no uncertainty, these are for 5%, this is 10%. There's not a lot of difference with the 5, but you can see as we increase to 10, these increase. What I'm plotting here is the 50th percentile, 5 percentile, and the 97.5 percentile. With the 20%, we see that we're simulating a lot more variability. So you can add these parameter uncertainty as well as sigma uncertainty between the replicates. Here's an example when I'm only modifying the sigma. I have a simulation of this model. I'm doing predictive check. And I'm indicated that my epsilon is 0.3. If I run this simulation and calculate epsilon for each replicate, the mean is all around 0, and the standard deviation is, as expected, close to 0.3. So I'm sampling from this normal distribution with a mean of 0 and a standard deviation of 0.3. If I added sigma uncertainty by using this new statement, as you see here, I'm now going to add this between replicate uncertainty of 0.1. If I do the same, I run this simulation and I calculate the epsilons and summarize them, the mean remains close to 0, but now in that distribution, my standard deviations are not close to 0.3, but instead they vary per replicate. If I do a summary of that, you can see that they vary with the variance close to 0.1, as I indicated in the variance covariance V fixed effect statement. So in summary, this statement allows you to incorporate parameter uncertainty and sigma uncertainty between the replicates. Now in simulation, we sample fixed effects from a multivariate normal distribution with the mean being the estimates, those that are in that initial estimate tab, and variance, and also can incorporate correlations by specifying a covariance. I didn't show you that. But in here, with a block, even though they have put a 0, this could be the space where for two parameters you would put the covariance between them. So this new statement now allows you another level of uncertainty in your simulations, probably a more realistic representation of the system being studied. NLME now also provides you an additional ordinary differential equation solver. As NLME users, you know that the ordinary differential equations are located at the bottom left of the Run Options tab. Now, in the drop-down, you will find this additional solver, the exponent HIAM. This new ODE is similar to the matrix exponent ODE solver in the sense that exponent HIAM option is another solver that uses the matrix exponent method for solving ODEs. Thus, it can only be used for solving linear ODEs with coefficients being constant over the time interval. The advantage of this solver over the default matrix exponent is that it resolves what is known as overscaling problem. So what do I mean by that? This diagram is an oversimplification, and I'm borrowing this graphic from my colleague Keith Neifert, as I find it useful to have this type of visual. The technique commonly used to numerically calculate the matrix exponent is so-called scaling and squaring method. The scaling is like breaking down a problem into smaller, simpler pieces to make it easier to handle. Then squaring is like bringing them back to their original complexity. If, for example, you have a dose that is in certain units and you change the unit so that dose is much larger now, when we're doing this scaling step, we might see this overscaling problem, meaning that this is scaled down more than necessary. And now the technique, when it tries to square it back to its original complexity, it has difficulties and it can significantly harm the accuracy of the results. Luckily, now in 8.5, if an overscaling problem is suspected with the matrix exponent solver, which is the default, a warning message is outputted to either the core status tags or in the warnings and errors tags output or both. For such case, it is recommended to switch to either the exponent HIAM solver or to numerical ODE, such as the non-stiff debug. In this slide, I'm showing you an example of the output where overscaling is suspected. Note that when I'm putting the estimated concentrations, the CP concentrations, they're estimated as being negative and very different from what was originally observed. In this case, this was not happening when a dose was in different units, much lower values, but when increasing the dose because we want them in different units, overscaling happened. One last comment about this is that we're discussing ODE solvers. So if your model is defined in closed form, you cannot encounter this overscaling problem. Closed form is the solution to the differential equations and the default for Phoenix built-in library models. And there, the ODE solvers do not come into play. NLME has also improved the way that QRPM engine calculates standard errors. The standard error calculations involve calculating the derivative of the log likelihood functions. In previous versions of QRPM, these derivatives are numerically calculated by finite difference method. The finite difference method usually gives reasonable good approximation, but sometimes the optimal step size cannot be determined, and this can lead to inaccurate approximations like we see here. In this particular model, the standard errors outputted by QRPM engine, you can see that are being underestimated. These are the red squares. Now, in 8.5, analytic derivatives are being used to provide more accurate standard errors for this engine, as illustrated on the right. Also, Phoenix 8.5 can now provide you additional model evaluation matrix that recent publications listed as the core set of plots that should be evaluated for nonlinear effects model fits of continuous data. As far as I know, these have not yet been mentioned in any regulatory guidance, but advances are happening quick in our industry, and Phoenix wants to provide model as potential diagnostic techniques that might help in model evaluation. So now in the Run Options tab of the maximum likelihood model, you can find this updated option. PCWRS is the predictive check weighted residuals, which already existed, but now has this /MPDE. When selected, this option will continue to output the PCWRS diagnostics, but will also output the normalized prediction discrepancy, as you can see in this residual worksheet. So we have the PCWRS, we have the NPD, and the NPDE. NPD stands for normalized prediction discrepancy, and NPDE stands for normalized prediction distribution error. So in the output, the simulation-based population prediction column is called PPRED. This is now presented instead of the predicted population PRED, and therefore the corresponding plots automated are going to be PCWRS versus PPRED. Sorry, this is cut off a little bit. You can see it better on this one, which is NPD versus PPRED. Then we also have NPD versus IBAR, the one highlighted here, and NPD versus STAT. All these are new, and QQNPD to check the normality of the NPD. These normalized prediction diagnostics are another widely used simulation-based metric for model evaluation. Following the best practice given in a 2017 ISOP tutorial paper, Phoenix now outputs these simulated diagnostics and their associated plots for all the population algorithms. These are optional and not selected by default. However, if you always want them in your output, you can set up a default object setting to always have this selection checked. The normalized discrepancy MPD that we just discussed can also be selected for continuous observations when doing BPC, so this predictive check right here. The user can now choose to output their MPD results, which will also be plotted similarly to the original BPC. These are in addition, as you can see here, we still have the ones that we're familiar with without MPD, and now we would have the quantiles and the confidence on the quantiles also plotted for MPD. And if the user selects MPD in BPC and the data is indicated as sensor for values below the A0 quantitation, the user has now three options on how to treat those when doing MPD. This is under the COPS tab of the predictive check. So when doing MPD, BQL values can either be ignored, sample, or they can be set to the lower limit of quantitation of the assay. And lastly, another improvement in Phoenix is the support for additional operating systems. Phoenix A5 supports Red Hat Enterprise Linux 8, CentOS 8, and can also support Ubuntu, a frequently used open source operating system on Linux. Maybe this is not exactly an NLME improvement, but a grid of remote service is often used by NLME users, as the modern run are computer intensive. This concludes the presentation on new capabilities on Phoenix 8.5. I hope you have found them useful. So now we will open the floor for Q&A. If you have any questions, please type it in the questions panel and we'll try to get to it. Don, please let me know if there are any questions.